Hi, the next topic is defining a function. So we can define any function in R. So this is the simplest example, one of the simplest examples. So f of x is equal to x squared. So we want to develop this function. Then at first we declare the name of the function. So we define the function named square here. Then this is a function. So we define this as the function parenthesis x, parenthesis, then brace, then x square, then brace. So then we have defined the function square as f of x is equal to x square. So after we defined this function, if we type square of 9, then we get 81. Square of 1.7, then we get 2.89, and so on. Okay, think about a little bit more complicated function. So remember that in our previous video, we want to find the smallest integer n such that the 2 to the nth power is larger than given number capital N. So this lowercase n represents the binary length. So length as the binary expression of capital N. So capital N is any number. So now we want to develop a function to return the lowercase n given capital N. So this is the function we can define. So given capital N, okay, so we define the binary length function. So this is the name of the function. And this is a function of capital N. And we start with lowercase n is equal to 1. Then while 2 to the nth power is less than capital N, we increase n by 1. Then finally, we finish this repetition, then we return n. So the output of this function is n. So to declare output, just you can type the output. Then after we defined this function, the binary length of the 1, 2, 3, 4, 5, 6, 7, 8, 9 is 27. Maybe we can run this function in the R console. So binary length function. So binary length. So capital N should be a positive integer. So 1 in the decimal system is also 1 in binary system. So length is 1, so it returns 1. So 2 is in binary system 10, 1, 0, right? So the length should be 2, and actually it becomes 2. And 3 in the decimal system is 1, 1 in the binary system. So length should be 2 and 2. And 4 is 1, 1, 1, 1, 0, 0 in the binary system. So it returns 3, and so on. So if we return 16, 16 is 1, 0, 0, 0, 0, so should be 5, and actually it is 5. So this is how to define the function. Here, the plus sign that also appears here. So this just means that the R run this code. So the code continues from the last line. So we are defining a function, and the definition has not been finished until this line. So that's why we have plus signs there. Okay, so next we want to get a little more general function. So we thought about decimal system to binary system, but in general, the q-adic system we can generate. So binary system 1, 1, 0, 1, 1, 1, 1, 1, and so on. But for example, the 3-adic number, that is the 1, 2, 1, 0, 1, 1, 1, 2, and so on. So last time we think about the 2 to the nth power, but this time that we think about the q to the nth power for general q, general the positive integer q. So the input of the function is not only capital N, but also q, the base of the power function. Then again, we start with n is equal to 1. Then while q to the nth power is less than capital N, we increase n by 1. Then finally, we return n. But also, okay, so this time we generalize the output that we put another output, the q to the nth power. So not only the n, but we can get the q to the nth power. If we define this function, the q-adic length of 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 is actually this. So actually the 17th. So 17 is the length when we express this number in 3-adic system. And this is the 3 to the 17th power. So if we put 2 here, then it returns the same output as the previous function, binary length function, but here that we generalized function. And also that we can set the default numbers for functions. So for example, the previous function, q-adic function, okay, so usually we want to think about the binary length. So 2 is the default value for q. Then we can specify this. And also, if you want, you can define the default value of capital N in this way. You don't have to, but you can specify the default value. So in this case, if we don't specify anything, the default value of 2 and this capital N are used. So it returns the same result as we give q is 2 and n is 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can change the q value here. Then we can get a different result. So this is how to define functions in R. And one note, you can set any objects as input of a function and the output of the function also. So sometimes, for example, we want to clean the data set. So input is the data set, so data frame in our object. And the output is the cleaned data set. So again, this is data frame. And we give parameter to clean the data. Then maybe input is a data frame and a parameter, and output is a data frame. So anything can be an input and anything can be an output of a function. And here is an example. So this is a little bit a simpler example, but a function whose input is a function. So this function f10 is this. So given function f, we calculate f of 10. If we input cosine here, then we calculate cosine of 10 radian, and so on. So if you defined this function in R, then f10 of square root is we evaluate this function at 10, so square root of 10, so it returns the 3.16. Hi, here is another example of using a function. So this is much practical example. So remember that it's cumbersome to overlay two XY plots. You have to have the same X scale, Y scale, the title, the same X label, Y label. So we have to adjust everything. So we can create a function to do it at once. So suppose that we have the two pair of data sets. So first pair is x1, y1. So first data, x coordinates of the first data and y coordinates of the first data, and x2, y2. So these are vectors, everything are vectors, and x2 are x coordinates for the second data, y2 is the y coordinates for the second data. x1 and y1 has the same length for example, 100, x2 and y2 has the same length, maybe 50. And we output the file as a JPEG file. So we want to do it at once in R. So an example, so suppose we are given x1, y1, we have the 10-dimensional vectors, and x2, y2, 15-dimensional vectors. x1, y1 makes a graph of y is equal to x to the power 1.1, and x2, y2 makes a graph of y is equal to x to the 0.9th power. Then we want to output this as a JPEG file. Maybe this is still not the most beautiful graph because x1 and x2 are overlaid here. So we have to put maybe x and y. But anyway, we want to make this graph. Then how to do that? You can define this function. I name it JPEG out2. So this is a function of x1, y1, x2, x2, y2. And dot, dot, dot is some options. So if we have more arguments that you can add. So this can be used for plot. The plot function have several options, such as character size or the sign for the points. So we can just pass through this to this place. So at first, given these vectors, that we calculate the range of x. So basically, we take the union of the range of x1 and range of x2. And y limit, y1, y2, so that all observations, to make sure that all observations are within our window. Then we create the JPEG file, the g1.jpg, and we make a plot. Okay, so the first one with the solid line, the line type 1, and we put x1, y1 scatter plot. We specify the range and the type line graph. Then we overlay, so parameter new is equal to true. Then we put the second plot. Then parameter new is equal to false, just to prepare for another figure. Then device.off. So this basically output the file. So we start outputting these objects, then finally we close that object and save the JPEG file. So this function. So given x1 to y2, so 4 vectors, the JPEG out to x1, y1, x2, y2 automatically output this JPEG file in your working directory.